Remember that we're following the integration what to do and when flowchart when doing integration. And remember that we've got the differentiation and integration formulae for trigonometric functions in your formula book. So, question 7, we're integrating sec squared 3x. We know that sec squared is going to integrate to be tan. So we'll have tan 3x, and then we need to divide by 3 because of the reverse chain rule. So we'll get 1/3 of tan 3x plus c. Here's the result here. We know that sec squared will integrate to be tan. Next, we're integrating cosec squared x with respect to x. So again, let's look at our formula book. And we were told down here in the differentiation formulae, we're told that cot differentiates to be minus cosec squared. So what that's telling me is the reverse is also true, that minus cosec squared is going to integrate to be cot. Therefore, cosec squared is going to integrate to be minus cot. So cosec squared is going to integrate to be minus cot x plus c. Next, we need to integrate sine squared. So first thing, double angle. For integrating sine squared or cos squared, we always start with the cos double angle. I know that cos 2a is equal to 1 minus 2 sine squared a. I'm going to make sine squared the subject, so I'll add sine squared to both sides, or rather add 2 sine squared to both sides, and I'm going to subtract the cos 2a. So just move that over there, so it's positive, move that over there. And divide both sides by 2. So sine squared is equal to 1/2 minus 1/2 cos 2a. That allows me to change this integral. So instead of being the integral of sine squared x dx, it's going to be the integral of 1/2 minus 1/2 cos 2x dx. The half at the front there will integrate nicely to be a 1/2x. We know cos is going to integrate to be sine, but because of the 2 on the inside there, because of the 2 here, we need to divide by 2 as well, by the reverse chain rule. So this minus 1/2 is going to become minus 1/4. So my answer will be 1/2 x minus 1/4 sine 2x plus c. Question 10. We've got the integral of x e to the minus x squared. First thing I note about this, the derivative of minus x squared is minus 2x, which is kind of similar to what I've got at the front here. So I think guess check would be a sensible idea here. I'm going to guess that my answer is just simply e to the minus x squared. And let's see how we get on with this. Let's check. Let's differentiate this and see whether my guess is correct. So when I differentiate the exponential, I get the exponential. But I need to multiply that by the derivative of the inside, which is minus 2x. So I'm going to multiply by minus 2x. So I guessed that this was the answer. I guessed that that was the integral of x e to the minus x squared. But then when I differentiated that, I actually found that it was the integral of minus 2x e to the minus x squared. So just comparing that to what I wanted, I can see it's 2 times 2 big and it's negative. So if I divide my guess by 2 and change it to be negative, so I'll have minus 1/2 e to the minus x squared plus c. And I'm pretty sure I've got that right. We can just do a final check if we wanted to. Let's differentiate what I've just done and see if we do get back to the original question. So when I've got this, if I differentiate the exponential, if I differentiate this, I will get that, nothing will change. But I'll need to multiply by the derivative of the inside, which is minus 2x. And the minus 1/2 times the minus 2 would cancel out to just be 1. And yes, we can see that this is the same as this. Therefore, this is the integral of this. Question 11. We've got the integral of x over x squared plus 1. I'm looking at that denominator, x squared plus 1, and I'm noting that the derivative of that is 2x, which is kind of similar to what I've got on the top. So guess check again. I'm going to guess that the integral of a fraction will be ln of x squared plus 1. Right, so let's check that and see, does that differentiate to give me the original integral? So differentiating the ln, I'll get 1 over. And then I have to multiply that by the derivative of the inside. So multiplying by the derivative of x squared plus 1, which is 2x. The 1 times 2x is just 2x. And let's compare. How close did I get with my guess? Almost perfect, just twice as big. This gives me an answer that's 2 times 2 big, so I need to half it. So the actual answer is 1/2 ln x squared plus 1. And again, we can do a final check if you would like, just to be super sure. Let's differentiate 1/2 ln x squared plus 1. So differentiating the ln, we get 1 over, multiplied by the derivative of the inside, which is 2x. And then we've got the 1/2 times the 1 times the 2x, which is 1/2 times 2x, which is just x. And that is what we started with, so this is correct. Question 12, we've got the integral of 3y minus 4 over y times 3y plus 2 with respect to y. First thing I might think is to try and do a guess check. I'm looking at the denominator here and seeing 3y squared plus 2y, but that would differentiate to be 6y plus 2, which is not like the top at all. So no, guess check's not going to work here. Instead, I'm thinking partial fractions. Let's rewrite this 3y minus 4 over y times 3y plus 2 as a over y plus b over 3y plus 2. Getting a common denominator, we'll have a times the 3y plus 2 plus b times the y all over y times 3y plus 2. Now the denominators on both sides are the same, so we can remove those and just compare the numerators. If I say let y equals minus 2/3, that's a good idea because this is now going to become 0. So I won't need to worry about the a part. The left-hand side, we've got 3 times minus 2 over 3, which is minus 2. 3 times this is minus 2. Minus the 4 is minus 6. As we said, this term here is just going to become 0 now. So then we just have minus 2/3 times b the negatives are going to cancel out. We'll times both sides by 3 and divide by 2. So the b is 9. Let me just write that out, working out in full. Sorry, I'm not happy with how I wrote that. So we're going to substitute the minus 2 over 3 in. That's me substituting it in on the left-hand side here. Substituting it in on the right-hand side, we've got a times, this is just 0, plus b times minus 2 over 3 on the right-hand side. Over here we've got minus 2 minus 4. The a times 0 is just 0. The b times minus 2 over 3. This is minus 6. And times both sides by... remove the negatives from both sides, times both sides by 3, and divide both sides by 2. So b is 9, so I can replace the 9 here. Right, let's now work out what a is. So this time I'm going to let y equal 0, because that's going to make this term here disappear. So I'll get on the left hand side 3 times 0 minus 4 is equal to a times 3 times 0 plus 2 plus b times 0. The left hand side is just minus 4. Then we've got a times the 2 so a is equal to minus 2. So all of that working allows me to replace the 1 fraction with minus 2 over y plus 9 over 3y plus 2. And now both of those can be integrated with logarithms to get minus 2 ln y plus 9 ln 3y plus 2. That's because of the reverse chain rule. I need to divide by 3. So the 9 over 3 will simplify to be 3. And not forgetting your constant of integration. So there we go.